In this test, we're going to manually configure and test a rose mount temperature transmitter configured with a thermocouple input with a range of 0 to 300 degrees C. We're going to measure the milliamp signal of the transmitter on the input of the 754, and we're going to power it with a 24-volt loop power supply internal. We're going to source or simulate a temperature signal to the input of the transmitter while simultaneously measuring the milliamp output and calculating error percent of span. To start the test, we want to measure milliamps and turn on loop power. Set up, enter, enabled. Next, we want to configure the source. Measure source to get to the source screen. Thermocouple. Type K. And to the split screen to do the calibration test. Select as found for an instrument. Configure what we're going to measure, 4 to 20 milliamps. .5%. Set the settling delay. And source 0 to 300 degrees C in a 3-point test. Select Auto Test. The calibrator will apply the 0% temperature input, measure for 4 milliamps, and calculate for error percent of span. Then change the temperature source to 50%, measure for 12 milliamps, and record the error. Then change the temperature source to the full scale input value, measure 20 milliamps, and record the measurement error. At the end of the test, we can see the temperature that was applied and the milliamp that was measured and the error percent being calculated for each point. And that's how you document a thermocouple temperature transmitter calibration using the Fluke 754 documenting process calibrator. In this test, we're going to use the Fluke 754 heart communicating calibrator to communicate with a heart smart temperature transmitter, identify its configuration, pre-configure itself for its test, document its performance, and perform the smart trim. Our connection, we have milliamp measurement connected to the power supply connections on the transmitter. We're going to provide 24-volt loop power from here and communicate to the transmitter over the milliamp signal jacks. We're going to simulate a Type K thermocouple to the input of the transmitter while simultaneously measuring its milliamp output. To initiate the test, we would select Heart and turn on loop power. In the initial handshake with the transmitter, we see the tag of the transmitter, its PV, and its input range. To configure it for the test, we'd press Heart one more time and select Measure Milliamps, Source TC Type K, and select As Found for an instrument. Input the test tolerance and select Auto Test to document the performance before adjustment. As it's testing, it's applying an input temperature, capturing the milliamp measured value, and calculating error percent of span. The 50% value is applied, and the 50% milliamp value is measured and calculated. Then the full scale value is applied, and the 100% milliamp value is measured. When the test is complete, you get the applied temperature, milliamp, and error percent of span for each test point. Tag, serial number, and the ID of the person doing the work are recorded. In the event that the test had failed, we could select Adjust and perform the output trim and sensor trim on the smart transmitter. First, we're going to perform the output trim, fetch the 4 milliamp value, and send to make the adjustment. Continue to adjust the 20 milliamp point, fetch, and send. Next, we're going to trim the input to the transmitter, the input A to D. We're going to trim the lower range value first, then continue and trim the upper range value. After adjustment is complete, we can document the as left condition of the transmitter after adjustment and perform the auto test and automatically record the applied temperature, measured current, and error percent of span after adjustment. First the 0% value, then the 50% value, then the 100% value, all being recorded to memory for later upload. You can see the applied temperature, current, and error percent of span. All errors in forward video indicate the test passed. Done. Tag serial number and ID. Done. And now we've documented the performance of a HeartSmart temperature transmitter using the Fluke 754, documenting process calibrator with Heart. In this example, we're going to test a RTD input temperature transmitter using the Fluke 754, documenting process calibrator. We're going to power the transmitter and measure the milliamp signal measured back on the milliamp input jacks of the calibrator. And we're going to simulate an RTD input into the transmitter while simultaneously measuring the milliamp output signal. To initiate the test, select Measure Milliamps and turn on loop power. Next, we want to configure the input to the transmitter, the RTD source of the calibrator. Select thermocouple RTD and RTD, PT100 385, input a temperature, and then move to the split screen to document the calibration. We document the calibration as found for an instrument. We're going to measure 4 to 20 milliamps to a test tolerance of 0.5% while sourcing 0 to 300 degrees C. We're going to test 3 points. Select Auto Test, and the performance of the transmitter will be recorded. 0%. 4 milliamps is being measured, error percent is being calculated. The 50% value is applied, milliamp measured, and error percent being calculated. Then the 100% temperature value is applied, milliamp value is measured, and error percent is calculated. When the test is done, you have the documented applied temperature, measured current, and error percent of span for each point. None of the error percents are in reverse video, indicating that all the milliamp measured values were within the allowable test tolerance, and the transmitter passes the calibration test. It's done. Tag serial number and ID of who did the work. Done. And we're done because it passed the test. And we have completed documenting the performance of this RTD transmitter using the 754 documenting process calibrator. We're going to test a Rosemount HeartSmart transmitter configured with an RTD input. We're going to measure the milliamp signal with the Fluke 754 and power it with the loop power supply. We're going to simulate a PT100 385 RTD while simultaneously measuring the milliamp output. Since it's a digital device, we'll communicate with the transmitter Heart via the milliamp connection terminals. To initiate the test, we select Heart and turn on loop power to communicate with the transmitter. Once communication is initiated, we see the tag of the transmitter, the PV, PVAO, and the transmitter's range, 0 to 300 degrees C. We continue and configure the calibrator to measure and source the correct values. And then to initiate the test, we select as found to input the test tolerance. Test tolerance of 0.25%, sourcing 0 to 300 degrees C, PT100 385. And auto test to automatically document the applied temperature, the measured current, and the error percent of span. Next, the 50% value is applied. 50% milliamp value is measured, and error percent of span is calculated. Next, the full scale value is applied. Milliamps are measured, and error percent of span is calculated. When the test is complete, the applied temperature, milliamp value, and error percent of span is recorded. Select Done. The tag and the serial number and the ID of the person doing the work is recorded. Since the transmitter failed, we need to perform an adjustment. First, we'll adjust the output of the transmitter. We'll fetch the 4 milliamp value and press Send to adjust. Then we'll fetch the 20 milliamp value and press Send to adjust. Next, we'll perform an adjustment on the input of the transmitter. We're going to trim the lower range value first. Then we're going to trim the upper range value. Adjustment is completed. Next, we need to document the post-adjustment condition of the transmitter as left. And we'll automatically record and document those results. Applying the 0% value, measuring the milliamp current, and calculating error percent of span. 50% applied value, measured milliamps, error percent of span. 100% value applied, full scale milliamp measurement, and error percent of span. Test is complete and recorded. All errors are smaller than the required test tolerance, so they're indicated in forward video, indicating that the adjustment was successful. Tag and serial number and ID of the person doing the work. Done, and then done. That's how you calibrate a HeartSmart RTD temperature transmitter using the Fluke 754 documenting process heart calibrator. In this test, we're going to use the Fluke 754 documenting calibrator to document and test the performance of a temperature switch. This switch, we will be simulating a thermocouple to its input while measuring for the contacts to change state on its output with continuity measurement. To perform the test, we first want to measure resistance for checking the continuity of our contacts. And then we would toggle to source. And we would source temperature, so thermocouple, type K, and type an input temperature value. To perform the documented test, we select Measure Source to get to the split screen, then select As Found. And we would perform a one-point switch test. We define the set point as being 20 degrees, and below 20 degrees the contacts are shorted. We then type in the rest of the test tolerance of 1 degree, minimum deadband of 1 degree, maximum deadband of 3 degrees, and we're going to trip on continuity as the switch opens and closes its test. We select Auto Test and continue, and the calibrator will source the temperature back and forth across the set point, and will narrow its temperature swing until it has a good identification. Once it's done finding the set point, it will then go back and redefine the reset point accurately and give us our test summary. Post-test summary, you can see the recorded set point, the found error from the set point, the reset point, the size of the deadband, and since the set point error and deadband errors are in forward video, that indicates that they meet the test tolerances and passes. That's how you test a temperature switch using the Fluke 754 documenting process calibrator.